Hello everyone, welcome to our lesson. In this lesson we are going to study mass and weight. Mass and weight is in the chapter of 3 for grade 9 and form 1, we can say. In chapter 3, title is force, and we are going to study mass and weight. So let's see in this video what we are going to study. The content is mass. First of all, we define what is mass, and we talk about the properties of mass, and then we go and discuss about the weight. What is weight of object? We discuss about the weight. Then next we will discuss about the relationship between mass and weight. Then we talk about the differences between the weight and mass. Then at the end we solve examples. Okay, let's what is mass? What is mass? Mass is the quantity of matter present in an object. Quantity of matter. How many quantities are there in the object? Okay, and for example 2 kilogram, 3 kilogram, 4 kilogram, 5 kilogram. Okay, so the number of quantities. Okay, the number of matter, the quantity of matter present in the objects. So mass is represented by M. Okay, not capital M, because capital M is called magnification in physics, so it is represented by the small m. And SI unit of mass is kilogram, so it is represented by kg. Okay, so mass is constant everywhere. Yes, this is important. Mass doesn't change. So if you take 2 kilogram object on the surface of the earth, that is 2 kilogram. If you take to the moon, 2 kilogram. If you go, take it away from the surface of the earth, again it is 2 kilogram. So on the surface of the earth, if mass of the object is 2 kilogram, okay, this is, let's say, earth. So if you take the object to the moon, so the mass of the object is again 2 kilogram. Mass doesn't change. Mass is same everywhere. And mass is a scalar quantity. Why mass is a scalar quantity? Because mass does not have the direction. Okay, it has its just magnitude and size, no direction. For example, we say 2 kilogram, so this is the size of the object. Okay, but there is no, it has unit and it has size, so this is 2 kilogram. 2 kilogram is the SI unit, and 2 is the its size or value. Okay, so there is no direction of the mass. That's why mass is a scalar quantity. So scalar quantities are called what? And the quantities those do not have the direction. It has just value, or let's say size, and SI unit. So mass is measured by beam balance. So you see, this is the beam balance. Okay, beam balance. So mass is measured by the beam balance. This is very common balance we see. Okay, in our daily life also we use it. Okay, so what we see then, mass is a quantity of matter in an object, present in an object. Mass is represented by m. Mass, SI unit of mass is kilogram. Mass is constant everywhere. Mass is a scalar quantity, and mass is measured by a balance, beam balance. So let's discuss about what is weight. Weight of object is a measure of pull of gravity on the object. Weight is a measure of pull of gravity on the object. Okay, so suppose that we have this, you see this guy is sitting, okay, boy is sitting under the tree. So you see, for example, here we have the apple, and apple is moving in the downward direction. So when the apple is dropped from the tree, okay, by tree, so you see the apple is moving in the downward direction. Okay, so it moves towards the surface of the earth. Okay, so you see apple is here, first jump, hit on the head of, hitting the head of the guy, then again bounced, then come to the towards to the center, towards to the surface of the earth. You see this also here, when it is coming down, it's also towards the earth, isn't it? So, and when after bounce from the head of the guy, say again it is moving in the downward direction. Okay, so why the object is moving in the downward direction? Because this apple is attracted by the earth. Okay, it is pulled towards the earth. So this pull is called what? Gravity. So the pull of gravity on the object is called what? Weight. For example, we have object here, and if we leave the object, you see this object is, when we leave it, it doesn't move towards the right or towards the left or in the upward direction. It moves in the downward direction. Why? Because there is a pull of gravity acting on the object, attracting objects towards the surface of the earth. So that's why the object is moving in the downward direction. So this gravity pull is called the weight of object. So because of this weight, we are on the surface of the earth. Objects are on the surface. If there is no weight, so all the objects will just fly in any direction. So this is the advantage of this force which we are facing. So it is attracting all the objects towards the center of earth. So the pull of gravity is always directed towards the center of the earth. So for example, I have this is earth. So this pull of gravity is towards the center of earth. Okay, so for example, I have object here. The force acting pull is again towards the center of earth. For example, object is here, so this pull of gravity is again towards the center of earth. That's why we can say that the pull of gravity always towards the center of the earth. Okay, if that is moon, so it is towards the center of moon. You see here we have example in this picture, you see, so there is guy, so it is pulled towards the center of earth. So this pull is called what? Pull of gravity. So here you see again pull of gravity. The object is, so on the surface of the moon, it is, the guy is attracted, pulled towards the center of moon. But when you have the earth, it is again attracted towards the center of earth. Okay, so next one, the weight of an object varies from place to the place. Yes, for example, if we say that the weight of this guy is here on the surface of moon is 100, or let's say 1000 Newton, so it means that here it is 160 Newton. You see, weight of object changes, okay, from place to the place. Even if we have moon on the surface of the moon, if the on the surface of the moon, if the weight of the object earth on the surface of the earth, let's say, if the weight of object is, let's say, 10 Newton, okay, at the surface of the earth, but when it is you take away from the surface of the earth, then it will be less than 9 Newton. Okay, but you see it is less than the weight on the surface of the earth. So that's why the weight of the object changes from place to the place. Next one, weight has both direction and size. So for example 10 Newton, for example this guy we said what it has 100,000 Newton force, isn't it? So the size of this force is 1000 Newton and its direction is, again we say, towards the center of earth. So that's why weight has direction and size. Weight of object is always towards the center of earth. So weight is it has a direction, that's why weight is a vector quantity. Okay, and weight is represented by W. Okay, W is the symbol of weight. So and if you write, for example, a small w, so small w is not weight, it is angular velocity. It is angular velocity, it is not weight. So that's why in physics when we are going to use the symbol, so we have to go for proper symbols. Okay, so the capital W is mass, the weight, and the small w is angular velocity. Okay, SI unit of mass weight is Newton. Why? Because Newton, because it is a force, and weight is measured by a spring balance calibrated in Newton. So you see this is a spring balance. Okay, so here on the this side we have the mass of the objects, so here we have the weight of the object. So this scale is calibrated in Newton and this scale is calibrated in mass. So weight is measured by the spring balance. Okay, so what we see here, okay, let's revise it. Just weight is a pull of gravity acting on the object. Weight is always towards the center of earth. Weight of object is changes place to place. Weight has both direction and size. That is why weight is called a scalar quantity, vector quantity. Weight is represented by the capital W, SI unit of weight. So in the next one, let's see relationship between the mass and weight. What is relationship between the mass and weight? So for the to determine the gravitational here in this one, we are going to see first of all what is the relation between the mass and weight. Is it weight is directly proportional to mass or inversely proportional to mass? Okay, first we will see. Then by the help of this information, then we will determine the gravitational field strength of a place. Gravitational field strength, how much gravitational field is strong. To determine gravitational field strength of place, we have to use some to find it. We use some standard masses of 20 grams, and we will use spring balance calibrated in Newton. This is such just experiment we are going to do. Okay, on the in this video. So we use standard masses of 20 grams and we use spring balance. Okay, let's see how we will do. So these are the spring balance, standard masses of 20 gram. You can find 10 gram, you can find in the labs, 5 gram you can find, 2 gram even you can find, and 1 gram even is available. In this experiment, of course, we will use 20 gram. Okay, to determine the gravitational field strength of a place. Then we are going to use spring balance. Okay, these two. So 20 gram masses, standard masses, and spring balance we are going to. So relationship between the mass and weight. Let's see. Okay, for example, here I have standard masses and I have a spring balance. Let's see. So at the beginning there is no mass suspended. There is no mass suspended, okay, on the spring balance. So that's why, okay, there is no weight measured here, okay. So you see here I have grams, okay, 0 gram, 100 gram, 50 gram, I have 300, and up to the 1000 gram, means 1 kilogram I can measure, okay. And on this side what I have, 0 Newton, 1 Newton. On this side I have 0 Newton, 1 Newton, 2 Newton, 3, up to the 10 Newton we can measure. So let's do the experiment. So I have what standard masses, and I change to convert masses to the kilogram. 100 kilogram is equal to 0.01 gram, 200 kilogram is equal to 0.2 gram, 300 gram is equal to 0.3 gram, and 400 gram is equal to 0.4 kilogram, and 500 gram is equal to 0.5 kilogram. So we are going to find out the weight of the object. So what I do, first I take 100, okay. Standard masses of the 100 grams are suspended to the spring one by one. The weight is measured on the spring balance for each masses. Let's do. Okay, first of all I keep 100 gram on the spring balance. Okay, 100 gram means 0.1 kilogram. I keep on the balance, spring balance, and I will see that the measurement here is the Newton, the weight is, or the Newton weight is measured is 1 Newton. Then I put one more 100 gram, okay, one more 100 gram. So it means that I have now 200 gram mass, okay, 200 gram mass. Then what will be the reading? So when it is 200 gram, so the weight of the object will be 2 Newton. So this indicator, this pointer will be here, okay, it will move in downward direction. For example, and then I am adding 100 more. Now total weight is 300, total mass is 300 gram. So it is 0.3 kilogram. So when we put 300 gram, so the indicator will be on the 3 Newton. Okay, so 300 gram is equal to 200 Newton weight. Okay, so then I put one more. So now we have 400 gram, and the mass of object is total mass is 0.4 kilogram. So then 400 kilogram. Now the reading on the Newton will be, okay, Newton will be 4 Newton. Then I add 100 more. Now I have 500 gram, total 0.5 kilogram. Then in the 500 gram is equal to, the weight of 500 gram is equal to 5 Newton. Okay, so here you see I increase the masses of the object, okay, let's say 0 to 100, 100 to 200, 200 300, 300 to 400, 400 to 500. So the changes is between each step is 100 gram. Okay, how about here? And even you can say 0 to 0.1, 0.1 to 0.2, 0.2 to 0.3, 0.3 to 0.4, 0.4 to 0.5. So the changes is 0.1 kilogram. Okay, so when I do the equal changes, so the weight also changes. 0 to 1, 1, 1 to 2, 1, 2 to 1, 1 Newton, 2 to 3 to 4 1 Newton, 4 to 5 is also 1 Newton. Okay, so you see the changes in the mass is equal, and the changes in the weight is also equal. So when the weight mass increases, so weight of the object is also increases. So that is why we can say that mass is directly proportional to weight is directly proportional to the mass. Weight is directly proportional to mass. Okay, directly proportional. When you increase the mass of the object, so the weight of object also increases. This is the result which we have found: 0, 1, 2, 3, 4, 5. Okay, so let's draw the show it by the graph. So draw the graph of mass weight on x and y axis. So put the values in the graph. So x axis is mass of the object, and the y axis is weight of the object, which is in Newton and which is in kilogram. In kilogram, mass should be in kilogram. So let's see, when the mass of object is 0, so the weight of object is 0. This is the point. Okay, so when the mass of object is 0.1, the weight of object is 1. Mass of the object is, let's say, 0.1 and the Newton is 1. This is the intersecting point. So 0.2 mass and 2 Newton. 0.2 mass, 2 Newton. Okay, 0.3 mass and 3 Newton. This is 0.4 mass and 4 Newton. 0.5 mass, kilogram, and what is weight? Weight of the object is 5 Newton. So let's draw the diagram, the lines from 0 to the last point. So we got a straight line. Okay, so this is going to show that yes, weight of object is directly proportional to the mass. So when the mass is increases, the weight of object also increases. When mass of the object increases, so the weight of object also increases. When mass of the object decreases, so the weight of object also decreases. They are directly proportional to each other. So relationship between the mass and weight is directly proportional. Okay, now let's find the slope of this diagram. Let's find the slope of the graph in this is equal to what? So you see here, slope of this diagram is equal to the it will give us is equal to weight over mass. Weight over mass. Why? Because here perpendicularly what we have weight of the object, and horizontally we have mass of the object. Okay, so x is mass and y is weight of the object. So let's find the slope. Slope is giving to us what? Weight over mass, and then let's write one by one. Okay, so first of all, let's say I'm going to the x-axis. I select 0.1 kilogram mass, which is equal to 1 Newton. So I come and write in and formula weight over mass. So 1 Newton over 0.1. Then I go and select, let's say mass of 0.2 kilogram is equal to the 2 Newton. Okay, 2 Newton. Okay, then I go and select 0.4 kilogram, which is equal to the 4 Newton. Okay, 0.4 kilogram and 4. Then lastly I go and let's say I took 0.06 kilogram, which is going to give us 6 Newton. So 0.6 kilogram is always also equal to 6 Newton. Okay, this is in the we have found. So 0.8 kilogram is equal to the 8 Newton. Okay, so you see 2 over 0.2 is equal to 10. 4 over 0.4 is equal to 10. 6 over 0.6 is equal to 10. 8 over 0.8 is equal to 10. 1 over 0.1 is also equal to 10. So it means that so from the here we found 10. From all this calculation we are always finding a 10, isn't it? So 10 Newton per kilogram is here a constant. Okay, so weight over mass is always a constant and its value is equal to 10 Newton per kilogram. So what is meaning of this? Meaning of this one, if you divide the weight of any object to its mass, so the answer is always 10. So you have this object, you divide its mass or its weight by its mass, so answer is always 10 Newton per kilogram. So it is going to show that, okay, weight or its mass of the weight of object to the divided by its mass is always constant. This constant is equal to this constant is called gravitational field strength of the earth. Okay, this constant is called gravitational field strength. If this is, we are talking about the earth, so this gravitational field strength of earth. If you are talking about the, let's say, moon, so this is gravitational field strength of moon. Okay, but this for earth is gravitational field strength is 10 Newton per kilogram. Okay, so it is represented by the G. Okay, G is gravitational field strength. The value of this slope is called the gravitational field strength. Yes, what is value? The value is 10. Okay, so gravitational field strength on the surface of earth is 10 Newton per kilogram everywhere. If this is for on the surface of earth. This is gravitational force on a unit mass at that place on the surface. For example, I have this is surface of the earth and I have 1 kilogram mass. So gravitational force acting on this object is 10 Newton. Okay, on the unit mass is 10 Newton. So if I have 2 kilogram mass, it means that 20 Newton force is acting on the 2 kilogram mass. If I have 3 kilogram mass, it means 13 Newton force is acting on it. So 3 multiplied by 10, 3 multiplied by 10, 1 multiplied by 10, 2 multiplied by 10. Per unit there is 10 Newton gravity force acting on the objects. So on the surface or on the Earth's surface, an object of mass m has a gravitational pull of mg on it, where g is acceleration due to gravity. So the g is in the sum is also called gravitational. Okay, gravitation. G is is also called gravitational acceleration. Gravitational acceleration. How we are going to find this formula? We are going to find this formula because now we said the weight of object is weight over mass of object is constant, isn't it? Constant. And this constant we said it is called what? G. So here you do cross multiplication. So MW is equal to the mg. Okay, W is equal to mg. So the weight of object W is equal to mass multiplied by gravitational field strength of gravitational acceleration. Okay, so you see here we have a book, let's say. Okay, so we have a book. So the weight of object is in the downward direction towards the center of earth, and the weight of object is equal to mg, mass multiplied by mass of the book multiplied by gravitational field strength. Okay, mg. So the earth pulls each kilogram of mass on its surface with a force of about 9.8 Newton, which is we take 10 Newton per kilogram. Actually it is 9 on the surface of what is 9.8, but we accept it as a 10 Newton per kilogram. Okay, let's do some examples. So here what we have, a dog, example 1, a dog of mass 3.5 kilogram. Find the weight of the dog. Okay, so which formula we are going to use? Formula is W is equal to mg. Okay, so what is mass? Mass is 3.5 kilogram multiplied by g. G is 10. So answer is 35 Newton. Okay, so let's find. Mass is 3.5 kilogram. Gravitational acceleration is, or gravitational field strength is 10. So 3.5 multiplied by 10, answer is 35 Newton. Question number 2, a pen of mass 20 gram, find, yes, so find the weight of the pen. Okay, so here again W is equal to mg, but here mass is 20 gram, so which is equal to 0.02 kilogram. Okay, so 0.02 multiplied by 10, which is equal to 0.2 Newton. Okay, so let's see the solution. Okay, 20 gram is equal to 0.02 kilogram. Gravitational field strength, gravitational acceleration is 10, so 0.02 multiplied by 10, so it's equal to 0.2 Newton. Example 3, a truck of 6 ton. Okay, so we are going to find again the weight of truck. Okay, so again same formula, weight is equal to mg. So what is mass? Mass is 10 ton, isn't it? So 1 ton is equal to how many kilogram? 1 ton is equal to 1000 kilogram. So how many kilogram ton we have? 6. So the answer is equal to 6000 kilogram. Okay, this is 1 ton. Okay, so 1 ton is equal to 1000 kilogram. So total mass is 6000 1000 kilograms. So 6000 multiplied by 10 is equal to 60,000 Newton. Okay, let's see the answer. So 6 ton mass is equal to 6000 kilogram. So the right formula mg, 6000 kilogram multiplied by 10, so 60,000 Newton is the mass, for the weight of the truck. Example one more. An astronaut weighs 1800 on the moon, okay, and 300 Newton on the 1800 Newton on the earth and 300 Newton on the moon. Okay, so we have, let's make question easy. So we have an object here. This is earth. Okay, on the surface of the earth the weight of object is 1800 Newton, but on the moon, so the weight of object is 300 Newton. Okay, so what is gravitational equation is calculate the gravitational field strength of the moon. So gravitational field strength of earth is for earth is 10 Newton per kilogram. This is we know. So what is question is gravitational field strength of moon. We will find. Okay. So let's here in this question, what we don't know? We don't know what mass of the object, isn't it? So mass of the object we don't know. First of all, we have to find the mass of the object. So on the earth, what is given in the question? 1800 Newton, the weight of the object, and gravitational acceleration or strength, field strength is 10 Newton per kilogram. The weight of object on the moon is 300 Newton given in the question. So let's put formula. Okay, so what is formula? Formula is same, weight is equal to mg. Okay, weight is equal to mg. This is the common formula. Okay, so if object is on the earth, on the surface of earth, so the w earth means the weight of the object on the earth is equal to mass multiplied by gravitational field strength of the earth. You see, this is formula which we are using. Okay, weight is equal to mg. So the object is on the earth, so the weight is equal to object of the earth, object of the weight of the object on the earth, and gravitational acceleration of the object on the earth multiplied by mass. So from this equation we can say that mass of the object is equal to the weight of the object on the earth, okay, over gravitational field of the earth. Okay, so what is the weight of the object on the earth is 1800 Newton, and gravitational field strength of the earth is 10. So we have found the mass of the object, which is 118 kilograms. So 1800 over 10 is equal to 180 kilogram is mass of the object. And remember, mass doesn't change. Mass is same. Mass of the object is same everywhere. So let's find for moon. So the weight of the moon object on the moon is equal to mass multiplied by gravitational field strength of the moon. Gravitational field strength of the moon. So same formula. So from this formula we can say that yes, gravitational field strength of the moon is equal to weight of the object on the moon over mass. So weight of the moon object on the moon is already given in the question, which is 300 Newton, but the mass we have found here 180 kilogram. So let's put in the formula weight of the object 300 Newton, and the mass of the object is 180 Newton. 300 over 118 is equal to 1.2 Newton per kilogram. This is gravitational field strength of moon. Okay, so next one is, let's see differences between the mass and differences between the mass and the weight. This is a common question, so we have studied already. Just let's write. Mass is the quantity of matter, but the weight is the pull of gravity on the body. Weight is a force. Mass is the quantity of matter in an object. So next one, mass, SI unit of mass is kilogram. SI unit of the Newton for weight is Newton, because weight is a force. Mass is the same everywhere. Mass doesn't change place to the any place. On the moon, on the surface, on the mountains, on the beach, on the another planet. So the mass of the object doesn't change, but the weight of the object changes place to the place. Okay. So for example, on the surface of the earth, if the mass weight of the object is 1000 Newton, on the surface of the earth it will be 160 Newton. A lot of difference is there. But on the surface of the earth, if mass of the object is 100 kilogram, so on the earth that is also 100 kilogram. Mass of the object doesn't change. Okay. So it is measured by using beam balance. It is measured by using a beam balance. A mass is measured by using a beam balance, but the weight is measured by a spring balance. Weight, mass of the object is a scalar quantity, but the weight is a vector quantity. Why? Because weight has a direction. Okay, this has no direction. Okay, this has no direction. So these are the differences between the mass and weight. Okay, we have finished the lesson today. For more details, for assignments, for the extra papers, for questions, and for PowerPoint presentations, slides, please visit our website and video lessons. For more lessons, more details, and more topics, visit our website www.ncdphysics.weebly.com. If you liked our lesson, you enjoyed the lesson, please like this video and subscribe to NCD Physics. Thank you for watching us.